The arch can be a very efficient structure. In this case, we're going to look at a special type of arch called a three-hinged arch. We're going to determine the reactions for this specific example, and the key concepts we're going to use are dividing structures into members and applying equations of equilibrium. And here's our arch. Notice that it is not symmetric and that we have both horizontal and vertical loads applied. We want to determine the horizontal and vertical components of the external reactions at A and C and the internal pin at B. And here's our approach. I'm going to start by approximating the solution. That way we'll have something to compare against after we've done more lengthy calculations. We'll then divide the structure into members. We'll confirm that it's determinate. Because otherwise that would change our approach. Once we've confirmed that it's determinate, all we need are equations of equilibrium. Once we've found all of those internal and external reactions, we'll compare with our approximation and decide if we have a reasonable answer. Let's get started. Step 1. We're going to approximate the solution. To do that, we're going to make a couple of crude assumptions. We're going to consider the effects of loads only in the direction of the loads. Because this is an arch, the forces applied will generate both horizontal and vertical reactions. But instead, what this assumption means is that we're going to treat it like a beam instead. The other thing we're going to do is ignore the internal pin. We know that moment is 0 at a pin. And so by treating it as a single solid beam and ignoring that internal pin, that's going to cause our approximation to deviate from our final solution sum. So let's look at the vertical load first. So we'll approximate our arch as a horizontal beam. We have our 4 kips downward force, and then we'll have reaction AY and reaction CY. At some moments, about point C, we'll pick counterclockwise as positive. AY causes it to rotate around the other direction. And our distance here is 4 feet, and then we have 22 feet for a total of 26 feet for AY. Then we have the 4 kips acting in the direction of positive moment through the distance of 22 feet. So AY will estimate as being 3.4 kips up. That's some forces in the Y. We'll choose up as positive. We have the 3.4 kip reaction at A minus the 4 kip download plus CY. CY is approximately 0.6 kips. Now let's take a look at the effect of the horizontal load. So we'll consider our arch to be a vertical beam this time, with the 3 kip load, AX and CX. And this distance is 3 feet between the line of action of the 3 kips applied horizontal load and AX, and then we have another 5 feet between AX and CX. Let's sum moments about point C. We'll choose counterclockwise as positive again. We get 3 kips acting through 8 feet, AX in the opposite direction acting through 5 feet. That means AX we predict to be approximately 4.8 kips in the direction drawn. Some forces in the X. We'll choose to the right as positive. We have the 3 kips applied force in the opposite direction. Our estimate of AX and CX. So CX will approximate as 1.8 kips in the opposite direction of AY, or AX. Step 2. Let's divide the structure into members. So we'll cut it at the reactions and at pin B. Get 2 reactions at A, AX and AY. At the cut, since it's a pin, we get BX and BY. And at C, we get 2 reactions as well. Step 3, let's confirm the determinacy. Otherwise, we're going to have a very different step 4, since equilibrium alone won't be sufficient. We have 4 external reactions, the 2 internal unknowns. We have 2 free bodies, so we have the 4 plus 2 unknowns minus the number of equations of equilibrium we have. 2 free bodies, 3 equal equations per free body. Those add up to 0. Therefore it appears determinate, but we need to check our reactions. They are not all parallel. We have X and Y reactions. The reactions are not concurrent. The line of action of the 4 reactions do not all pass through a single point. Therefore, it is also stable. Now we know that it's okay to apply equilibrium and obtain all of the information we're looking for the arch. Now step 4. Apply equilibrium. So I'm going to start with a free body diagram of member AB. We have our reaction AY, reaction AX. The applied downward force of 4 kips, 4 feet, and 7 feet. We have our unknown BY, our unknown BX, and this is a height of 5 feet. Let's sum moments about point A. And this time I'll choose clockwise as positive for my summation, because the 4 kips causes a clockwise rotation through 4 feet. BY causes a clockwise rotation through 11 feet. And don't forget, BX also contributes, and that is through 5 feet. So if I solve for BY, BY is a minus 1.454 kips minus 0.454 BX. We'll call this equation 1. Now, let's draw a free body diagram of member BC. We have vertical reaction CY, horizontal reaction CX. We have the horizontal force of 3 kips, our unknown BY, our unknown BX, our total length here of 15 feet, a height to the 3 kip applied load of 8 feet, and then another 2 feet to point B. Let's sum moments about point C. We'll go counterclockwise as positive this time for our summation. BX through 10 feet causes counterclockwise rotation. That one's positive. But BY acts in the opposite direction through 15 feet. And the 3 kip applied load causes counterclockwise rotation through 8 feet. So if I solve this for BY, we get 0.667 BX plus 1.6 kips, and I'll call this equation 2. Well, notice equation 1 is BY equals something, equation 2 is BY equals something, which means this side and this side must be equal. So we'll set equation 1 equal to equation 2. We get a minus 1.454 kips minus 0.454 BX equals 0.667 BX plus the 1.6 kips. So if I move the forces all together on one side, the BX's all together on one side, and solve for BX, I get a negative 2.72 kips. Remember, this was an internal to the structure, and we drew positive as such. Now with this value, we can substitute back into equation 1. BY equals negative 0.22 kips. Remember, we drew that such that on the left side of the cut we drew BY down, on the right side of the cut, we drew by up. Now let's use our information about the cut at B and our free body diagram of AB to find the reactions at A. The reactions AY and AX, our applied load of 4 kips. We said BX was a negative 2.72 kips, BY a negative 0.22 kips. Some forces in the x direction we'll take to the right as positive. We have AX and a negative 2.72 kips from BX. AX is a positive 2.72 kips. It's in the direction we drew it. Some forces in the y. Take up as positive for our summation. We have AY minus the 4 kips applied load minus, because it's drawn down, but a minus 0.22 kips at BY. AY is a positive 3.78 kips in the direction drawn. Now to find the reactions at C. So we'll go back to our free body diagram of member BC. We have the reactions CX and CY. A horizontal applied load of 3 kips. BX a negative 2.72 kips, and BY negative 0.22 kips. We'll sum forces in the x direction. Choose to the right as positive for our summation. We have a negative because it's drawn to the left, but the magnitude is negative for BX. 3 kips is to the left, and CX we've drawn to the right. We solve for CX and we get positive 0.28 kips in the direction we drew it. Now we sum forces in the y direction. We have drawn up, but a magnitude of negative 0.22 kips. CY we've drawn up. CY is a positive 0.22 kips in the direction we've drawn. Now we're ready to make our comparison with the approximation. To do that, let's summarize what we calculated. We found AY to be 3.78 kips up. We found AX to be 2.72 kips to the right. We found CY to be 0.22 kips up, and we found CX to be 0.28 kips to the right. At the pin at B, we found the vertical components to be negative 0.22 kips, and we found the horizontal components to be a negative 2.72 kips. And to refresh our memories, our approximation gave us the following results. We had ballparked 3.4 kips up at AY. We had ballparked 4.8 kips to the right at its AX. We had predicted that CX would come back the other direction and that we would have 0.6 kips vertical. Now we completely ignored the benefit of the arch when we made our approximation, which will affect the x direction values significantly. When we look at our y value comparisons, they came out very well. Our order of magnitude comparisons for the AX or the x values worked out well. So I would say we have reasonable agreement given our assumptions. All right, let's go back and review the process we followed. We started by creating an approximate solution that we could use, that we could create quickly, and that we could use to evaluate our results at the end after our more detailed calculations. We ignored the arch action and considered the structure to actually behave more like a beam. We considered the vertical force and the horizontal force independently. And then divided the arch into its members, confirmed that it's determinate and stable so that we can use equilibrium to find all of the forces we need. We then applied equilibrium to each of the free bodies in order to get the forces at B. We then went back to free body of member AB to find the reactions at A, and the free body of member BC to find the reactions at C. We then compared our calculated results with our approximated results, found that they were in reasonable agreement given the crudeness of the assumptions we make, so we feel like we have reasonable results for our prediction of the reactions and force at pin B for our 3 hinged arch. Well done.